Are you worried about the Chinese catching up and getting ahead?
There's a good chance that they are the leaders at some point.
A year ago, that question would have sounded ridiculous. China was never supposed to lead the AI race because China's AI breakthrough was supposed to be impossible. America controlled the world's most advanced chips. China was cut off from them. The logic seemed simple. No advanced chips, no advanced AI. But then something unexpected happened. China built one anyway. A breakthrough that many people believe should not have been possible. America's greatest advantage was not just the technology, it was monopoly. The world's most advanced AI systems were built on a foundation only a few companies could provide: the chips, the manufacturing, the supply chain. And China needed access to that ecosystem. That dependence gave America something more valuable than a lead. It gave America a leverage, because a competitor who needs your technology is easier to influence and control. So when the United States restricted China's access to advanced AI chips, the logic was straightforward: limit the chips, slow the progress, protect the advantage. But there was an ancient lesson hiding inside a modern arms race. Ironically, it was one China had known for centuries. Sun Tzu said in The Art of War, when you surround an enemy, leave an outlet free. Do not press a desperate foe too hard. A desperate foe turns into a cornered beast. When people or soldiers have no way to escape, fear goes away, and they fight with wild, absolute strength. Leave a small open space so they focus on running away rather than fighting to the death. Once they turn to flee or compromise, they become much easier to defeat. Kevin O'Leary, the millionaire from Shark Tank, described this strategic idea using a simple analogy.
The NVIDIA chip, we need to sell it to everybody, even adversaries, because within that country of Russia or China is some genius kid, you don't know who he is or she is, that's going to write the next piece of firmware or advance AI from the queen bee, the chip, the American queen bee. The minute you shut down a market and you don't, your adversary sends their queen bee in, which is Huawei. We can't let that happen.
The United States controlled the most important resource in the AI ecosystem, the chips. So the winning move was not necessarily to push China completely out. It was to keep them inside, give them weaker chips, keep them dependent, keep their companies invested in the ecosystem. Because once a competitor has billions of dollars tied into your system, walking away becomes expensive. The sunk cost becomes leverage. A dependent competitor is much easier to influence than a desperate competitor. That is the paradox of the AI chip war. America removed China's easiest path forward, but it also removed China's dependence on America. Instead of asking, how do we build the biggest possible model, Chinese researchers had to ask, how do we make every chip count? Moonshot AI's Kimi K3, for example, uses a massive mixture of experts design, where only a fraction of the model is activated for each token, improving efficiency compared with running the entire system every time. We will delve deeper into the architecture in Chapter 3. Just as Sun Tzu warned, this technology should not exist. It was a miracle born out of desperation. What do you do when a Chinese AI model becomes number one? Moonshot AI's Kimi K3 had entered the front-end code arena in 18th place, then it jumped to first. Not first among Chinese models, first. It beat Claude Fable 5 in 6 of 7 front-end design categories. Now, Kimi did not dominate every measure of intelligence. It didn't need to. It had already crossed a much more important line. Chinese AI was no longer merely cheap enough to tolerate. It was becoming good enough to choose. For decades, the phrase "made in China" carried a familiar reputation: cheap, fast, mass-produced, but rarely the best. The assumption was simple: China copied, America innovated. China competed on price, America competed on quality. But Kimi presented a possibility most people were not prepared for. What if the Chinese alternative was both? What if it was cheaper and better? At this point, should America ban Chinese AI? The White House is divided. Most people think a ban will protect American companies. But no, it primarily protects American AI labs. Those are not the same thing. OpenAI and Anthropic may benefit from having fewer competitors, but every other American company becomes their customer, and customers do not benefit when the government forces them to buy the more expensive product. Chamath saw this problem and posted the bluntest version of it. He said the AI market had already split into two options: closed American models costing between $26 and $56 per million tokens, and open weight Chinese models costing between 50 cents and $1, forcing American companies to pay 50 or 100 times more for AI. Would be like the government telling Americans you can only buy oil for $800 a barrel, while the free market sells the same oil for $80. A government can stop its own citizens from choosing a better product, but it cannot make the protected product better. And America cannot ban Chinese AI from the rest of the world. The cornered beast had found an outlet: the global market. But there was another problem. Kimi was not hidden inside a secret Chinese laboratory. Moonshot made it open weight. American labs did not need to steal China's breakthrough. They could download it, which raises the obvious question: why couldn't America simply copy it? Because seeing the answer is not the same as rebuilding your entire system around it. Kimi's efficiency comes from activating only 16 of its 896 specialized experts for each token. On paper, that sounds perfect. Why wake up the entire brain when only a few specialists are needed? But there is a catch. Those experts are enormous. They cannot fit on one GPU. They can't even fit inside one server. They have to be spread across hundreds of different chips. Every time Kimi processes a token, its router must decide which 16 experts are needed. Then it has to send the information to the GPUs where those experts live. Moonshot did not make the GPUs faster, it made them talk less. But American AI infrastructure was built for a different kind of machine. US labs spent years optimizing their data centers for dense computing, massive amounts of information moving through tightly connected clusters of the world's best NVIDIA chips. The hardware, software, and data pipelines were all designed around the same brute force philosophy. When you need more intelligence, add more computing power. Kimi's architecture works differently. Its advantage comes from sending less information to far more specialized parts of the model. Adopting that system is not just a software update, it's rebuilding the pipelines underneath the model itself. American researchers can read the algorithm. They can understand the solution, but they cannot simply inject it into GPT or Claude, because the router learns how to use its experts during training. By the time a model is finished, those pathways are already built into its brain. Changing them is not like installing a new feature. It is closer to rewriting the brain after it has already learned how to think. To adopt Kimi's approach properly, an American lab needs to train an entirely new model, a new architecture, a new routing system, a new data pipeline, months of work, in a training run that could cost hundreds of millions of dollars. The software is free, the migration is not. Ironically, the copycat had become the innovator. The hardware disadvantage created the software advantage, and now the cornered beast has learned how to compete without the world's best chips, which leaves one final question. What happens when the cornered beast is no longer cornered? Only 20% of people watch till the end. If you have gotten this far, let us know in the comments. For more arbitrage content, click on the video to the right.